In the previous video, we analyzed an HR analytics example, and we showed that the two most important effects explaining that the employees were leaving the company were the satisfaction and the number of years since the arrival of the employee at the company. We used a table to report those effects, but we can do better. We can use a plot instead to report our effects. And actually, now that we know what are the most important effects, we can even use a method that does not rely on statistics to help our audience to understand the situation. This is called a model-free approach. Let's first take the example of the time an employee spent within the company and its relation to attrition. Since we're willing to find a visual representation of the relationship between these two variables, we could just use the plot function in R and report the fact that the employees left or not as a function of the time spent in the company. But if we do that without preparation, we obtain this plot. And we directly see a problem. Since the variable is binary, it's either 0 or 1, you'll have at least 1 1 and at least 1 0 for every year we're considering, from 2 to 6. The problem then is that we don't know how many observations are zeros and how many observations are ones. So instead, we could aggregate the values and compute the mean attrition rate by year spent with the company. We then obtain this graph, which is a lot better. What do we see? As time goes by, employees are, as expected, more likely to leave the company. The attrition rate increases from year to year. In year 2, the attrition rate is close to 0, but in years 3 and 4, it goes respectively to 17 and then 24%. And after 5 years, employees are on average around 44% likely to churn. And it's not cumulative. It basically means that if you pick 2 employees who are at the end of their 4th year randomly, by the end of their 5th year, one of them probably left. We should definitively investigate why we cannot retain those employees. Is it because the salary doesn't increase steeply enough? Is it because we fail to propose a decent career plan? It may be exogenous. It may be somehow out of our hands. For instance, because employees didn't intend to stay more than 4 years in consulting anyway. But in any case, it should be investigated. And we should do our best to at least retain the employees that are performing well. We'll discuss how we could prioritize our actions during the next module. There is something strange though. We see that in year 6, while the attrition rate is still dangerously high, it decreases a bit compared to year 5. What does that mean? Could it be that there is a non-linear and non-monotonous effect? Meaning that it starts increasing and then it decreases. Or could it be that it's just noise in the data? To assess it, we can compute the number of observations related to each dot. And we could, for instance, make the same plot as before, but with the size of the bubble proportional to the number of employees in that case. We then obtain this plot. And we see that the bigger group is actually the 3-year-old employees. And that the smaller group is indeed the 6-year-old employees. On the other hand, if you compute the exact number, you will see that this group has 512 observations. Even though it's the smaller one, we cannot really say that it should be disregarded. It may actually be an interesting case of self-selection. Those who stay even after passing the threshold of 5 years are those who will stay even longer. It's something that we very often see in marketing as well. At some point, your customers that are still loyal to you after many years will probably stay loyal forever. The same with employees. Now, let's focus on another factor, the one we identified as the most important, satisfaction. This case is a bit more complex because in contrast with the time spent that took only 5 different values, satisfaction is an index and can take any value from 0 to 1. So, to be able to plot it on a graph in the same fashion as what we did before with the time spent, let's rank the satisfaction from the most satisfied employees to the less satisfied ones. And let's compute again the average attrition rate by groups of similar satisfaction ranking. We then obtain this plot. Let's look into the details because here we observe very interesting non-monotonous effects. First, we have the very satisfied employees. They report a low risk of leaving the company. And we also have what I'd call the "it's okay" employees. Not very satisfied, but they are okay and they won't move. Now in between, we have something very strange. The employees that are satisfied, but still not enough, since they present a higher risk of leaving than other employees that are more or less satisfied. It's probably those employees we've discussed during the second module on finding groups within data. Good performers, but either they worked too hard and were burnt out, or they were probably recruited directly by the client. In the case of the burnt out, they were not as happy as they could have been, so they left. And in the case of the high performers, their level of satisfaction was not high enough to retain them from leaving. In any case, those are probably the guys we should do something about. As a follow-up exercise, I would advise you to look at what's their level of performance using the evaluation variable. Finally, we have the very unsatisfied employees. As expected, those guys report a very high level of attrition, and we should do something about it. Understanding why they are unsatisfied, if solvable, may reduce the employee attrition of the company. But we should first check that we are sure we want to keep them. Again, the evaluation variable should be included into the reflection. But I'll let you play with the data yourself. Actually, since we observe highly nonlinear effects, a more advanced model, such as a decision tree or ensemble methods, would probably perform a lot better than a simple logistic regression. I invite those of you who are eager to use those techniques to practice on this dataset. But don't forget to avoid the black box syndrome. Very accurate model is nice, but when you're trying to understand a situation, an insightful model is better. And the challenge with more advanced models is usually that their output is more complex to interpret. To wrap up on the HR analytics case, I'd like to emphasize how we came to produce the results we presented. We first build a model and make sure that the model is reliable. We then identify the most important factors and report their relationship with the outcome visually. We finally use a model-free representation of our results. You may have noticed that in this video, we didn't use directly the results of the regression for the graphs. The regression was used to identify the most important factors, and only then we reported visually the effects of those factors, but without using the estimates directly anymore. Since what we saw was consistent with the results of the regression, it was reliable. But thanks to this model-free approach, we could go further in the interpretation and enhance our conclusions using visual clues which allow us to observe complex effects. And it didn't require that your audience understands anything about statistics. This approach could be replicated to any type of sector, any type of application, and any type of variable. Also with more advanced models. It's the combination of rigorous statistical techniques with the articulation of insights presented visually that will allow us to build a shared representation of the reality with our audience. As we will discuss at the end of this training, this is key to ensure the success of any change you want to implement for your business.